keyboard here in a minute. A little slow today. There we go. All right, we're recording Tuesday, 3/18, geometry first period, and we are on section 9-6, and it starts in Braille on page 383A. 383A. And it's a theorem. 382 kind of goes through an exercise with a bunch of lined paper to get to this theorem, but we're just going to engage our brain about parallel lines and transversals, and the theorem should make sense. Okay? Think about all your different angles that occur with parallel lines, and this new proportion theorem should make sense. So up at the top, it's theorem 9-8, and it says, if three or more parallel lines intersect two transversals, the lines divide the transversals proportionately. So if we have three parallel lines, that's the trick. Two parallel lines, there wouldn't matter because there would only be one piece that we would be looking at. But when we have three, we end up with three or more, we end up with two or more sections of the transversal. So let's take a look at what they're talking about with the graphic. So there's three parallel lines running east to west or west to east. The one on the top is labeled line L off to the right, and it has a parallel indicator in the middle of it. Then there's a middle line just below that labeled M, and it has a parallel indicator in the middle of it and two arrowheads on each end. And then there's a line at the very bottom, line N. It's also parallel indicator. Find all those? Okay. And it has two transversals, one on the left going from about 1 o'clock to 7 o'clock. And it has three intersection points. The top intersection point they're labeling A off to the right. The intersection point with the middle line they're labeling B. And the bottom intersection point with the bottom line N they're labeling C. And that C almost runs into the line. So you're going to have to be careful reading that, but just know it's A, B, and C. So there's two segments, isn't there? Well, there's three. There's AB, there's BC, and then there's AC, right? That transversal. Okay. Then on the right, there's another transversal all the way to the right intersecting the three lines, and it's pitched from about 11 to 5 o'clock. And it intersects at D, E, and F. Okay, D, E, and F. So we have segment DE, segment EF, and then segment DF for line DF. Okay, so what they're saying in this theorem is that if it's going through three or more lines, the segments are proportionate. So AB is proportionate to BC, which equals DE to EF. Okay, so those equal each other. AB is to BC as DE is to EF. And then you could say AB is to AC, the whole thing, as DE is to DF. Okay? Or you could say the bottom part, BC is to AC, as EF is to DF. Okay? Do you see all those? All right? So three or more parallel lines, transversals, divide proportionally. Two transversals, the lines divide proportionally. Okay? So that we're going to use that theorem to do some work. So turn the page to the next example. First, we're just going to practice what is proportionate to each other in this example by completing proportion statements, okay? So you're drawing, your parallel lines on this drawing run from about 2 o'clock to 8 o'clock parallel to each other, okay? So there's 3 parallel lines running on that 2 o'clock to 8 o'clock diagonal. Does that make sense? Okay, and they have 3 parallel indicators going through the midst, right? And then your transversals, let me get all these written though. They didn't label the lines at all. They didn't, other than they just showed their parallel with the parallel indicators. But they did label the points that the transversals intersect the lines at, so we're able to label the proportionate sections. So there is a line, a transversal at the top that's kind of going through it at about 9 o'clock to 3 o'clock, going through those 3 lines. That's a transversal, and it's transversing our 3 parallel lines at point M on the far left, point N on the middle line, and point P.
Oh, that's a P.
Yeah, the P kind of runs into our line, so it looks like a Y or an and. So M and P, all right? Those are the intersection points. Then down at the bottom, there's another transversal that's skewed to running from about 10 o'clock to 4 o'clock. And it intersects our 3 parallel lines at R, S, and T, all right? So let's practice what is proportionate to each other. So MN is to NP as RS is to ST. Good. Let's try MN is to MP as RS is to RT. Use your graphic to find the order. RT. Good. Okay. Then let's do the second part. NP is to MP as ST is to NP. Nancy, Peter. NP is to MP. So the second segment up top to the whole segment as ST is to RT. Good. All right? So you just be really careful how you name those. But they're all proportionate because we have 3 or more parallel lines being transversed twice. Those transversals will be proportionate to each other. All right? Okay. Let's see. What else does it say? It talks about, since it discusses it, since MR is parallel to NS is parallel to PT, the transversals are divided proportionally. Therefore, MN is to MP as RS is to RT. Use the figure above to complete the proportion. RS is to ST as MN is to NP. We already figured that out, didn't we? All right. It says you can use proportions from parallel lines to solve for missing measures. So the next example has us doing some math with it. So turn the page to 383C, and it asks, it says use in the figure A is parallel to B, which is parallel to C. See that? Little letter A, parallel B, parallel C. Okay. Find the value of X. So we have 3 parallel lines running east to west. And they've labeled them A, B, and C off to the right.
Off to the right?
Italicized A, B, and C. All right. So those are running 9 o'clock to 3 o'clock, 3 o'clock to 9 o'clock. They don't have parallel line indicators. They don't have to because they gave that to us in writing, right? They told us they're parallel. So then we have 2 transversals. C is at the very bottom. Let me keep moving down. Keep moving down. There you go. All right. So you find all 3 lines. Okay. Bryant, how you doing?
Good.
Okay. All right, we have two transversals. We have one on the left. And it's going through 3 points. Point G at the top, point H at the middle, and point J at the bottom. Off to the left, is 12 from G to H and 18 from H to J. See that? Okay. Then all the way over to the right, we have a transversal. It intersects line A at U, line B at V, and line X at W. From U to V is 15, excuse me, and from V to W is X. We have to find the value of X. How would you like to do that?
We have to use ratios.
Yeah, use ratios. 12 over what, Abby? 12 over 18 is equal to what? No. 15 over X, yes. Always keep them in the same order. So 12 is to 18 as 15 is X. It's kind of set up that way on your paper, isn't it? So what are you going to cross multiply?
12 times X.
12 times X, all right. 18 times 15 or 15 times 18? So 12X equals 270. X is 22.5. Okay? Pretty basic, isn't it? All right. There's another drawing 2 pages later. We got to really take our time with this a little bit because they squished 2 parallel lines together up at the top. All right, so go 2 pages over, 384. And we have 2 very tight parallel lines up at the top that they're going to try to squish all the braille around. All right. And they say in the figure L is parallel to M is parallel to N. So we have 2 lines L and M up at the top that are very tight to each other. It runs into the braille.
Why did it do that?
It's how much? 5. Yeah.
Right.
You see that? All right, so that's 5. And then from B to C is 30. Okay. Then you go over to the far right. There's a transversal that's looking like it's running from about 12 o'clock to 6 o'clock. And it intersects the top 2 points at, they're labeling it R and S. They squeezed it in there. And that is an X value on that piece, that little piece. And then the S to T down at the bottom where it intersects is 20. All right. And then, on the other transversal, it intersected at C. So from A to B, it's 5. From B to C, it's 30. from R to S, it's X, and from S to T, it's 20. What is the value of X? 5 over 30. No, careful.
Okay.
X over 20, right.
Oh, yeah.
5 is to 30 as X is to 20. All right, cross multiply.
5 times.
What do you want to say, Bryant? 5 times what?
X.
Nope.
5 times.
Oh.
It'd be cross multiplying. So 5 is to 30 as X is to 20. What are your outsides? 5 and 20.
20.
5 times 20 is 100.
100.
And then divide by 30.
30.
3 and a third? All right, good. So that's how you do those. Be very careful with those. It's probably a good idea to set them up right on your brailler so you can see the outsides and the insides and not try to remember which one is the outside. All right, turn the page. We're going to discover something really cool with Theorem 9-9. So we got to do some reading. It says, suppose 3 parallel lines intersect a transversal and divide the transversal into congruent segments. Refer to the figure below. The transversal on the left is divided into congruent segments. Is this true of the other 2 transversals? Find the values of X and Y. So there's 3 parallel lines running east to west. Pretty large graphic. All right, they've got parallel indicators. Okay, there's a middle one. Find that one. Okay, and then there's one at the very bottom. There's your 3 parallel lines. The one at the bottom is missing an arrowhead on the left. Yeah, but it is still there. All right, there's a transversal on the left that's running from about 2 o'clock to 8 o'clock. Okay. And it is saying that the first segment is 5 and the second segment is 5. Aha. And then there's another transversal running from about 12 o'clock to 6 o'clock. And it's saying it is 4 to X. Well, what is X? 5 is to 5 as 4 is to X. What should X be? If 5 is to 5, 4 should be to what?
4.
You can do 5 times 4 is 20 divided by 5, but if you have a 1-to-1 ratio, you better have a 1-to-1 ratio, right? So 4 is to 4, okay. So then we go all the way over to the right, and we find our other transversal that's running from about 10 o'clock to 4 o'clock, and the first part of it is a Y, and the second part of it is a 6. Well, what is Y? If we have 5 is to 5 as Y is to 6,
6.
6. Oh, interesting. Okay. So here's another theorem on the next page. Well, the next page goes through us talking about all those. So 2 more pages. 384C. So Theorem 9-9, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal, right? That just means the parallel lines are the same distance from each other, doesn't it?
Yeah.
And so if they're the same distance from each other, they're going to make congruent pieces in any transversal because their distance is the same, right? And so it shows 3 parallel lines, just like what we used in the previous drawing. They're labeling these off to the right, line L, M, and N. They've got parallel indicators on them, so get practiced at looking at those, right? All these lines. Okay, I'm drawing them on my book here for print users. Parallel indicator on the middle line, and then the bottom line, N goes east to west. And it too has a parallel indicator. And then there's a transversal on the left. and it intersects through point A, B, and C, and a transversal on the right that intersects through D, E, and F. And down below, they're explaining this theorem in symbols. If L is parallel to M is parallel to N, and AB is congruent to BC, then DE is congruent to EF. They have to be proportional. They're going to have to be congruent. All right? So let's practice this one. Let's see. Oh, it just goes right into check your understanding. Okay, great. All right. So number 1 has us write at least 3 proportions if A, B, and C are parallel to each other. So we got this traditional drawing that you're used to looking at in this section of 3 parallel lines and 2 transversals, one on the left and one on the right. And they have intersection points at each one of those transversals. So see if you can find those. You're labeling your lines off to the far right. All right. Okay. The left transversal intersects at D, E, and F. Okay. And the right transversal intersects at what? G, H, and J. Okay. So let's name some proportions. DE is to EF as what?
As GH is to HJ.
Good, as GH is to HJ. Good. How about HJ is to GJ as
D.
HJ, so find HJ on the right. HJ
H.
is to GJ, so the bottom one. HJ is to the big one. GJ as no EF. Start with the bottom. EF. If you had HJ on the right at the bottom, you got to start with the bottom on the left. EF. EF is to
EF is to D.
F.
G.
Good. EF. Good. HJ is to GJ as EF is to DF. Okay? Good job. All right. However you label them, you have to label them the same order on the right? So if we went DF, the big one, is to DE, the little top, we have to do what on the right? DF is to DE as
J.
GJ is to
H.
GH, right? Okay, good. All right. It says, describe how you would find GJ if EF is 15, DF is 25, and GH is 12. So EF is 15, the whole thing, DF is 25, and GH is 12. What kind of things do we have to do to figure this out? Because we got to figure out GJ, the whole thing of GJ. Do we know the top portion of DF? Do we know DE?
Well,
We could. How could we, Jess? 25 minus 15 is 10. Excellent. All right. So now we know 10 is to 25, right? As 12 is to question mark, right? X, because we don't know GJ. That's what we want to find out. So you had to do a little subtraction first because you couldn't use the 15 because 15 is not in the same position as this 12. The DEF is not the same position as the GH. So you had to figure out the 10 first so that you could go corresponding part to corresponding part, right? So 10 is to 25 as 12 is to X. 10 is to 25 as 12 is to X. 10x, okay?
And
300. All right, x equals 3, doesn't it? Good. All right, move a couple of pages over to 385B. 385B. We're going to work on number 4 and 5. We're going to name complete proportions, all right? Number 4 and 5 are directly below the drawing. We have 3 transversals. Again, they look pretty familiar. They're kind of in the same position as the last few have been. Yeah. We have one on the top, running east to west. One in the middle, running east to west. And one on the bottom. And there's 2 transversals. One on the left and the right. Can't draw very straight lines today. All right, my parallel indicators. All right, one on the left. It's kind of pitched just before noon. It intersects at point M, N, and P. The one on the right intersects at R, S, and T. Okay? Help? All right, we have to complete the proportions down at the bottom. This is where we want to be very, very careful and detailed looking at our drawings and figuring out the right letters. So NP is to MP. So NP is to MP. That's what it says on number 4. As blank is to RT.
ST.
Good. You know, NP is to MP. So the bottom segment is to the whole segment, as blank is to RT. So the bottom segment on the right is ST, isn't it?
Yeah.
Okay. Number 5 down below asks us, ST is to blank as NP is to MN. NP is to MP. NP is to MN as ST is to what?
NP.
So ST is to blank as NP, the bottom segment, is to MN, the top segment. It's RS, that's right. Bottom segment to top segment, bottom segment to top segment. Keep them in corresponding orders, correct? Very carefully. All right, good job.
Did you know letters?
Okay, what's that, Abby?
Did you know numbers easier than letters?
Numbers are easier than letters? Well, sorry. Welcome to math. We like to use letters. All right. Example 6, number 6 wants us to find the value of x. So you have 3 transversals. 2 of the transversals are pretty close to each other up at the top.
Which one?
And then the third transversal, or not transversal, I'm sorry, parallel lines. 2 of the parallel lines are very close to each other up at the top. All right. And then the third parallel line is further down, halfway down the page. See it? All right. And then you have 2 transversals. The one on the left is running from about 2 o'clock to 8 o'clock. And it goes through the first transversal and second transversal, and to the left of it is saying that's 6 units. And then it goes through the third transversal, and to the left of that it's saying X units. The right transversal is intersecting our 3 parallel lines, and up at the top, the intersection at the first 2 is 4 units. And then the intersection of the middle and the third one is 12 units. So what is the value of x? You could do x over 6, okay? No, bad.
Oh, 12 over.
If you start with big over little, you got to have big over little.
Isn't that
So x over 6 is 12 over 4. That's fine. Or you could say 6 over x is 4 over 12.
how
Do
come?
not flip them.
Isn't that x is smaller than 12 though?
It's not about smaller than. It's about the corresponding parts.
Okay.
The little one corresponds with the little one. The bigger one corresponds with the bigger one, right? Corresponding parts. So 6 corresponds with 4. X corresponds with 12.
Okay.
Yeah, always keep them in corresponding part order. So 6 is to X as 4 is to 12. So how are you going to solve this?
Cross multiply.
Cross multiply. All right. What are we going to multiply?
6 times. Oh,
No.
12.
6 times 12.
So how I did it first? X over 6 and
So that's
12 over
72.
4. Oh, okay.
All right. 72 divided by
8.
18. All right. You need to write these out most likely. Trying to do them on the drawing and in your head, Abby Sue, you are if you write it in Braille, then you can see the outsides and the insides. When you try to look at a drawing, you get confused, don't you? All right. Let's take a look at the next drawing on the next page. We got an algebra link. It's kind of tight, but we can do this. We have 3 parallel lines running up and down that are skewed at about 11 o'clock to 5 o'clock position. Very tight, little tiny drawing. Okay, find your 3 parallel lines running from about 11 o'clock to 5 o'clock. Okay, all right. There's one on the left, one in the middle, and one on the far right. Find them?
Oh, yeah, I got it.
Okay. Then you have 2 transversals. There's one running from about 10 o'clock to 4 o'clock from the top left-hand corner. And the little piece that it's dividing up in the top, there's a little arrow pointing into that and saying that's x plus 1. Okay, so the little segment up at the top is x plus 1. The bigger segment is 6. The transversal is splitting up 2 segments, x plus 1 and 6. And at the bottom, the transversal runs from about 2 o'clock to 8 o'clock. And it's broken up into 2 segments, 2 and 4. Find the value of x.
So x plus 1 over 6
X plus 1 over 6
and 2 over 4.
equals 2 over 4. Good. All right. X plus 1 over 6 equals 2 over 4. How are you going to solve this?
4 times x and 4x.
4x what?
4x and 4 times 1.
4 times 1. Okay, so 4x plus 4
plus 4
equals
2 times 6.
2 equals 2 times 6. This is 12. Good. 4x plus 4 equals 12. Now what?
Minus 4x plus minus, so subtract from the other side.
Subtract what?
12 minus 4.
12 minus 4. All right, so 4x equals 8.
And divide. Oh, it's
And x would equal 2 then.
X equals 2. Excellent. Good job. All right. So does that all make sense? Yeah? All right. Be super careful with your proportions, all right? Okay? All right. Let's see. I think that's the end of this section. So tomorrow we're going to come in and take a quiz. All right. So we'll do a little warm up and then take a quiz. And then we'll finish. Then we'll do 9-7. And then that will be the end of this chapter, and we'll launch into the review Thursday, Friday. And I'll probably have you do the test as a take-home test you can do over the weekend.
On Friday?
Yeah. All right, everyone, that's all I have. I'm going to turn the recording off, but we can hang out and talk. There's about 4 minutes of class left.
Okay.